So let's, this is straight out of the book, it's example 2. Let's say you have a ranch and you got to build a road to the city. Okay, there's the highway. The road, of course, you'd want to be anywhere from perpendicular to angled. Okay, the question is, we're going to give you some constraints, but which road do you build? Where do you build the road so that you get to the city the fastest? Okay. This distance is 30 kilometers, and this distance is 50 kilometers. This is, the speed limit here is 60 kilometers an hour, and the speed limit here is 110 kilometers an hour. So we have all our information. The question is the fastest route going to be perpendicular or not? We don't know if it is or not. So I'm going to call this some distance x, because we need to consider that that's going to actually happen, that the road could be a diagonal. What's this distance? Pythagorean theorem. Okay, so that's a possible distance we can travel as well. All right. Okay, thank you for that. We also know that's 50 minus x in case we need it. Okay, so let's build our function here. Time is our objective function, right? So our objective is to minimize time. Does that look familiar? Dirt. Dirt, dirt, dirt. Okay, time is distance over rate. So what is our time function going to be for this problem? What's our time function going to be for this? Okay, so we have a distance and a rate from the ranch to the highway. That distance is this over 60. And we have to add the time for the highway. And that's going to be 50 minus x over 110. Okay. So that's our objective function. Do we have a constraint equation? Do we need one? Do we need a constraint equation? How many variables do we have right now? Just one. So we don't even need it. Does, doesn't it? 30 squared. Good point. We don't need a constraint equation because there's one variable for us to work with. That's kind of nice in this one. So now we're going to take the derivative, right? So that equals 0, etc. The hard part of this one's the setup. Okay, go ahead and do the derivative. I'm going to ask somebody for it when we get there. Anybody have the derivative?
Hold on, almost done.
Okay, no problem.
Well, actually, I do.
Everybody's writing advice. Like, tell them you watch Fox News, they'll dismiss you.
You have jury duty?
Yeah.
You're 18?
Yeah.
That's a bummer.
Yeah.
Is the derivative of 1/2 900 times negative 1/2 times 2x over 6 times 2x 6 over 3600 plus negative 100 over 12,160?
Sorry. I missed that.
That's okay. We're not supposed to simplify like this,
I got it in your wing. I got it.
Okay. What is it?
It is 2x over square root of 30 squared plus x squared minus 1 over 110 times 5 minus x squared.
After he solved the derivative, he put back the fraction.
You're pretty close.
Oh, man.
So we have to put back the fraction before we just leave it one straight line.
Okay, that last little bit you said, what was it, Leon? 5 minus something or other?
Yeah, 110 times 5 minus x squared.
Why do you have 5 minus x squared?
Chain rule.
Yeah.
It's not a chain rule. That second,
Yeah, I know what I did.
this, yeah, the derivative of this is just negative 1/10. You can rewrite it if you want. 50 over 110
minus x over 1/10. Okay, that's 0. And this is negative 1/10, which is what comes out of it. Okay. Don't make it more difficult than you need to. And if you really want to, this can be a 1x and this can be 60. 2 over 120 is 1 over 60. Okay. Okay, set it equal to 0. And solve.
Hey, Arthur, were you doing interpretive dancing for this hour?
Me?
Yeah, because there was like tranquil music in here.
Yes, it was tranquil music.
Are you dancing to it?
No.
That's your pump for your day.
Gosh. I would never do that. Because I'm a tough guy. And tough guys don't dance.
You changed 110 to 11.
Yeah, I did. I also changed 60 to 6.
What?
I divided each side by 10.
Oh, okay.
It makes the numbers smaller when you square them. You all right? Ben? What's 36 times 90? 32.4.
36 times 90 is 3. I got 3,240.
You left out the 2x.
What?
2x though.
You changed the bottom to 60.
Oh, we're stupid.
Yeah, 2 over 120 is 1 over 60.
Okay, go down. How did you do 32,000?
I'm going to bring this up here.
30 squared. Oh, okay.
Yeah, 90 times 36.
But 90.
Yeah, oh, sorry, 900. Yeah, good point. Divide by 85, square root it. Are we following the algebra?
Oh, yeah.
I see a mistake. All right, let's finish. Are you okay with the algebra? Ben, focus. Put the Rubik's Cube down. Okay, so Is that right there for sure our x value? And I asked that question, I probably could tell you that. That's not the definite minimum. Okay? We have to consider the endpoints. So we have to consider, because the objective function only gives us a critical point, we also have to consider the endpoints, 0 and 50. Okay, so if we go back to our objective function, our time function, we need to analyze t of 0, 19.52, and 50. Okay. T of 0, it ends up at almost an hour. 19.52 gives us 9/10, and then 50 is also almost an hour. So these come from plugging it in there. So I plug 0 in, then I plug it in and plug it in. So obviously the road needs to be 19.52 kilometers from the perpendicular intersection. Okay. Do you want one more? Okay. There's really 37. Okay, 37 is a very difficult problem. Give it a try. You don't have to do it now, but I'm just telling you that's the hard one. No, it's the hardest one. Okay, so let me know if you have any issues. I'm going to let you work now. Pretty much.